displacement on this axis. So this axis will be the displacement axis. Okay.
Yeah,
Now,
okay.
if you will see here, this yellow color line, if you are watching, then this is the straight line graph.
Mm.
This is the first graph, and this
Mm.
graph or this straight line of this graph or is
Mm.
just a straight line is lying on the time axis, lying on
Mm.
the time axis.
Yeah.
Okay. So what is the meaning of this? The meaning of this, you can see when you are changing time. Suppose here is time 1 second, here is 2 seconds. In this direction, the time will increase. In this direction, the time will increase. Suppose here time is 0, means starting point. Here time is 1 second, 2 seconds, 3 seconds. Now during as the time is increasing, you can see displacement is not increasing and displacement is 0. Displacement is 0. So basically, what we can conclude, time is passing on. Suppose I am sitting here, time is passing on.
Yeah.
My displacement is 0, 0, 0, 0 all time.
Yeah.
So means I am at rest. Means I will be at rest. So this is the
Yeah.
condition here. The displacement is 0 for any value of time.
Mm.
The displacement is 0 for any value of time. Any value
Mm.
of time. And the body is at rest. If this type of graph you will have, if this type of graph you will have, this type of graph, then you will say the body is at rest. Try to understand how I am telling. Okay, how I am telling,
Mm.
because when time is increasing, there is no increase in displacement. Displacement is 0 for all the times. Okay.
Mm.
Now next, this is the graph. This is again the displacement time graph. S is the displacement, T is the time. Now this is the graph now. This is the graph. This is the graph. So now you can see this is t is equal to 0, means here time will be 0. Time will be 0 means this is the initial condition from where the body is starting.
Mm.
Now on increasing time, you can see on increasing time, suppose T1, this T1 is suppose 1 second. T1 is 1 second. So displacement is corresponding to this T1, the displacement is
Yeah.
S1. Okay. Now corresponding again the time increases to T2. Now corresponding to this T2, what is the displacement? S1 again.
Yeah.
Now corresponding to T3, again the displacement is S1. Means time is changing. Time is increasing, but time is
Yeah.
changing. With time, the displacement is constant. Displacement is not changing. So from this graph, what we can conclude means initially the body have some displacement. Now you can see initially
Yeah.
the body have this much of displacement.
Yeah.
Body have this much of displacement. The body have, but after means after the time increases, after this point the time increases, the displacement is remaining same. Displacement is not
Yeah.
changing. Means you can
Mm.
say you can conclude from this graph, initially the body have some initial displacement, but after that the body is at rest.
Mm.
Okay, so the
Yeah.
displacement is constant and does not change with time. So displacement is constant and not changing with time. And after
Mm.
some displacement, initially the body has done some displacement, after that the body is at rest. Okay.
Yeah. Okay.
Now this is very important part, slope of the graph. Suppose
Mm.
this is a displacement time graph again, and this type of graph, straight line graph we have. This is a straight line. Straight line graph. So slope of this graph is given by displacement divided by time. Mean
Yeah.
y-axis, the quantity, the physical quantity on y-axis, and the quantity on the
Mm.
x-axis. Displacement divided by time. will be the slope of this graph. Slope of the graph is displacement divided by time. Now, what is the value displacement divided by time? Velocity. Displacement divided by time is velocity.
Yeah.
And slope is also given by tan theta. This is the one method, and this is another method. Slope is also given by tan of theta. This is the angle theta. This angle theta is with time axis or with x axis. Okay. So if this type of graph we will have, a straight line graph, always for a straight line graph, the slope will be constant. You can see this theta during the whole, means this theta is constant. Theta is not changing in this graph. Theta with time axis is not changing, means tan theta will remain constant. If tan theta will remain constant, means slope will remain constant. So you will say slope is constant. So now slope is what? Slope is velocity. So try to merge all the things. Slope is velocity, means if slope is not changing, means the velocity is not changing. Velocity is constant. So for a straight line graph, the velocity for the straight line displacement time graph, the velocity is constant. After that, suppose this type of graph we have. This is our displacement time graph, and this graph and this straight line is making an angle of 30 degree with the time axis. So for this graph, when we will calculate the slope, so slope is given by tan theta. Slope of the graph is given by tan theta, and what is the value of theta? 30 degree, and the value of tan 30 is 1 by root 3. So now this value is constant value. So you can say slope is constant. If slope is constant, then velocity is constant. And one more thing. If velocity is constant, then acceleration is zero, because acceleration is change in velocity divided by change in time. Velocity is constant means the change in velocity is zero. If change in velocity is zero, means acceleration is zero. So you can say acceleration is zero. Delta v by delta t means delta v is change in velocity. Delta v is change in velocity.
Okay.
And this change in velocity is zero. So you can say in this graph, the body is moving with uniform velocity means constant velocity. Suppose we have this type of graph. This is graph number 4. Suppose this type of graph we have. So this is a displacement, this is time, and this type of graph we have. So first what we will do now? First we will calculate the slope. And how to calculate the slope? We will draw a line parallel to the time axis. So this line and this line are parallel. And now we will see this angle. And this angle is given as 30 degree. This angle is already given. This angle is 30 degree. Okay. So first we will calculate the slope. So when you will calculate slope, so what is the slope of displacement time graph? Velocity. And slope is given by tan theta. Tan theta means tan 60. Tan 60 is root 3. So for this graph also the velocity is constant. For this graph also the velocity, I told you that if the graph is a straight line or 100%, the velocity will be constant.
Yeah.
Okay, so now at t is equal to 0. See, there is some initial displacement. At t is equal to 0, t is equal to 0 means initially. So initially there is some displacement. Initially, but after that the body is moving with a uniform velocity. This is the conclusion of the graph. Body has uniform velocity with some initial displacement.
Yeah.
Okay, so this question We will solve again. Okay. So you can see this is the first graph. This is the second graph. Okay. This is
Yeah.
the first graph. This is the second graph. And this is a straight line graph. This is also a straight line graph. This angle is 45 degree and this angle is also 45 degree. And given that the value of tan 45 is what? So four options are given. They are saying body 1 and 2 will have same velocity. They are saying both body 1 and 2 will have same velocity. Second option, both body 1 and 2 will have different velocity. Option number C, both have same initial displacement. Both have different initial displacement.
Hmm.
This is very easy. It means first we will get for finding the velocity. For finding the velocity, what we will do? For the graph number 1, we will find the velocity, and velocity is basically the slope, and slope is tan 45. Okay, velocity
Yeah.
from this graph. How we will get the velocity from this graph? Tan theta, and tan theta is tan 45, and tan 45 is equal to 1. So now calculate V2. V2 is tan 45 again.
Hmm. Yeah.
This is also 1. So this option is correct. Both the bodies have the same velocity. Both bodies have the same velocity. So this option number B is incorrect. Different velocity. So we can cut.
Hmm.
Now both have same initial displacement. Now see the initial displacement. Initially this body have zero displacement.
Hmm.
Initially the displacement of body 1 is 0. And initially
Yeah.
this body have some displacement. You can see
Hmm.
S2. So there will be some displacement that is not equal to 0 initially. So which option is correct? Both have same initial displacement. This is incorrect.
Hmm.
So it means that option number D will be correct. Now, if this type of graph we have, if this
Hmm.
type of graph we have, this is the graph. This is the graph. Okay, so you can see here, this is the graph between the displacement and time. And this graph is like this, straight line graph, and but like this. Now, see, this is the initial condition. This is the initial condition. T is
Hmm.
equal to 0 initially. Now move in this direction and calculate displacement at time t1. So this is time t1. So corresponding to t1, what you will do? You will draw a straight line to the graph, and there you will get a point on the straight line. And from that point, draw a perpendicular on the displacement axis. Then you will get the displacement of this
Hmm.
at time t1. So S1 is the displacement at time t1. Now at time t2, you are getting S2. Now which one is greater? S1 is greater than S2.
Yeah.
So if S1 is greater than S2, so what you can say? You can say with time displacement is decreasing. Hmm? This
Yeah.
displacement is greater than this, and this displacement for covering this displacement more time, for covering this displacement less time. So with time the displacement is decreasing. No, oh sorry. For covering this displacement, the time is less.
Yeah.
Means in less time, more displacement. In more time,
Hmm.
less displacement. Means displacement is decreasing. Displacement can decrease also. How displacement can
Yeah.
decrease? You can see here. Suppose a body is going in this direction.
Hmm.
Now the body is moved from A to B. Body moved from A to B. Now this body is returning. So when this body will return, the displacement will decrease.
Yeah.
Now come to the slope. Come to the slope. So for slope, there is a requirement of this angle. There is a requirement of angle with time axis. Okay.
Yeah.
And always remember, you can say here that, sir, I can take the angle like this also. No, we will not take angle in this way. Actually, we will always take angle anti-clockwise,
Okay.
not clockwise.
Okay.
And anti-clockwise from where? From the axis to the graph. Anti-clockwise from the axis to the graph. Anti-clockwise can be like this also. This is also anti-clockwise angle. But this is from graph to the line. Your angle should be from axis to the graph, and that should be anti-clockwise. Then you will get this theta. Now this theta is greater than 90 or not?
Yeah.
This theta is greater than 90 or less than 180. 180 means this flat. This angle will be 180 degree. But this angle is in between 90 to 180. This angle is in between 90 to 180. So what we can say about the slope, if the graph is in 90 to 180, the value of 10 between 90 to 180 will be negative. Between 90 to 180 degree, the value of 10 of any angle, suppose 1091, you will get 0 or not 0, some negative value. For example, 10 of 120 degree. So you can write this as 10 of 90 plus 30, and 1090 plus theta is minus cot theta, cot 30. So the value of the cot 30, what is the value of cot 30? 1030 is 1 by root 3. So it will be this, minus root 3. So you will get a negative slope. You will get a negative slope.
Okay.
So what is the significance of the negative slope? What is the significance of the negative slope? Slope is what? Velocity? Slope is what? Velocity means velocity is negative.
Yeah. Yeah.
So for this graph, what you can say, with time the displacement will decrease and slope of the graph will be negative. Okay.
Yeah.
So you can say slope of graph is negative. Now uses of displacement time graph. So with the help of displacement time graph, we can find the position of the body. We can find the this velocity of the body with the help of the slope. After this, we what was this is displacement time graph. Now we will discuss velocity time graph. Velocity time graph. So this is a velocity time graph, first velocity time graph. And remember, slope of velocity time graph will be acceleration. slope of velocity time graph will be acceleration.
Hmm.
Okay, I am telling you now how we can calculate the slope of the graph. Okay, I am telling you how to calculate the slope of the graph. Okay, so now you can see here. Take this graph, and this is the velocity, and this is time. Now take the straight line graph. Okay, this is the graph. So basically, to find the slope of this graph, what is the requirement? Angle.
Yeah.
If you know this angle theta, or what is the slope? What is the slope? Slope is tan theta.
Hmm.
Okay. So now see. This is some point. Suppose at this point the velocity is v1 and time is t1. At
Yeah.
this point on the graph, the velocity is v1 and time is t1. Okay, this is the point. Now take another point. Suppose at this point the velocity is v2 and time is t2.
Hmm.
So this point will be like this. Okay. Now see. Can you tell me this distance? Just a minute. Just a minute. What is this distance? This whole distance is what? This is v2. This whole distance is v2 because this is the. Oh, oh. Just a minute. Just a minute. Just a minute. A minute. Actually, this coordinate will be. Actually, we have to change only the coordinate. It will be t1 into v1. So this coordinate is x coordinate. We write first x coordinate, then y coordinate. T1 into v1, and this coordinate will be t2 into v2. Understanding?
Yeah.
So this distance will be y. What is the y coordinate of the graph? Y coordinate of the graph is distance between the point and the x-axis. So this will be the y coordinate, and this distance will be v2. And what is this distance? This distance will be v1.
Yeah.
So can we find this distance?
Yeah.
What it be? v2 minus v1.
Yeah.
Because this is a line and this is a line. You will subtract this line from this line. You will get only this distance, and this distance will be v2 minus v1.
Yeah.
Okay. Now we want to find this distance. This. We want to find this distance. This distance. This. Okay. So now this is v1 we know, and I am removing it. Okay. So I want to find this distance. So just tell me, can you tell me this distance from here to here? Can you tell me this distance? Will this distance be t2? See,
Yeah.
this is the point t2. So this point will be here. So this distance will be t2.
Yeah.
And can you tell me this distance? This will be t1
Yeah. T1.
because this is the point t1. So we can find this distance. We can find this distance now, t2 minus t1. And this line and this line are parallel. So this distance and this distance will be equal. So it will be t2 minus t1. Now we have a triangle. We have a triangle, and for this triangle, this theta is there, and we have one side of the triangle as v2 minus v1, another side as t2 minus t1.
Mm.
Can we find tan theta from this? Tan theta of the triangle is perpendicular. This angle is 90 degree. Okay, this angle is 90. Tan theta of the triangle is given by perpendicular divided by base. So if this is theta, na, so opposite to this theta will be the perpendicular or the altitude. So this, suppose this is A, this is B, this is C. So AB will be the perpendicular or altitude of the triangle. Perpendicular or altitude. And BC is the base of the triangle. And tan theta is perpendicular divided by base. So tan theta is V2 minus V1 divided by T2 minus T1. Now, what is tan theta for this graph? What is tan theta? Tan theta is the slope of this graph. So for this tan theta, you can write slope of the graph. And what is this? V2 minus V1, change in velocity. T2 minus T1, change in time. What is change in velocity divided by change in time?
Change in velocity over change in time. Change in velocity.
Think. Rate of change of velocity or change in velocity divided by change in time.
The acceleration.
Yeah, acceleration.
Hmm.
It will be acceleration.
Yeah.
Acceleration A. So that is why I have written here slope of velocity time graph will give acceleration. So basically this is the whole explanation why and how to calculate the means acceleration. I mean how to calculate the slope of any graph. I can tell you that also, that why the slope, why we are taking the slope of the distance time graph as velocity, because it will be come out to be change in displacement divided by change in time. Change in displacement divided by change in time is the velocity. So please write down this thing. This is very important. This is very important. So this will give you the idea how to calculate the slope. Understanding now?
Yeah.
So please write down this. And this is the straight line graph. So do you know na how to calculate? Do you know the properties of triangle? What is base? What is hypotenuse? What is perpendicular, altitude? So basically, this is the trigonometry I applied here. Trigonometry. With the help of trigonometry, I have calculated the slope. So you have to apply all your knowledge to solve a problem.
Okay, sir. Note it down.
Okay. So velocity time graph, slope is acceleration. Now you know why the slope is the acceleration. Okay, if this type of graph you will have a straight line lying on the time axis, it means that with time the velocity is zero. Okay,
Hmm.
velocity is zero. If the velocity is zero means body will be at rest. Hmm? Velocity is zero means
Yeah.
the body velocity is
Got it.
zero means the body is at rest. Okay, so
Yeah.
you can read this graph. Okay. Now another. If this type of graph we will have, so initially there is some velocity. Initially there is some velocity. Suppose initially the velocity is v1. This is the velocity v1 initially. Okay. And after this, after achieving some velocity, the velocity is becoming constant because with time the velocity is not changing. You can see with time t1 the velocity is same, with time t2 the velocity is same. So we can say initially the body is having some velocity, but with time the velocity is not changing and becomes constant.
Hmm.
Now if this type of graph, okay, one more thing you can apply here. uh, can you find the slope of this graph? Slope.
Uh,
Slope is what? Tan of theta.
hmm.
And theta should be with x-axis. Theta is the angle between the time axis and the graph. Now this time, this is time axis and this is the graph. What is the angle between both of these? 0 degree.
Yeah.
And tan 0 degree is 0. Slope
Yeah.
is also the acceleration. So means
Yeah.
acceleration is 0. And if
Yeah.
acceleration is 0 means velocity is constant.
Yeah.
So from here or from with the help of slope also, you can find that the velocity is constant. Okay, and with by analyzing the graph, you can find velocity is constant. Now come
Hmm.
to this point. This is the straight line graph making an angle theta. So this theta is theta, and when you will calculate the slope, so tan theta and the value of tan theta will be some constant. Means acceleration is constant. Means the body is performing uniformly accelerated motion.
Hmm.
Okay. So slope is equal to tan theta, and this will remain same, or you can say this is constant. So slope is acceleration and acceleration is constant. So the body is moving with constant or uniform acceleration.
Hmm.
Now this graph. If this type of graph we will have to find the slope, what we will do? We will draw a parallel line with respect to this line. Okay. And first we will find the slope. Okay. So slope of this graph will be tan theta. And
Hmm.
tan theta will be constant because this theta is not changing. And slope is acceleration means acceleration is constant. So body is performing the uniformly accelerated motion, and initially the body is having some velocity. At t is equal to 0, v1 is the velocity, means initially the body is having some velocity and the body is moving with constant acceleration. Now this question we will solve. Hello.
Yes, sir.
Hello.
Yeah.
Getting my voice now?
Yeah, I can hear you.
Okay. So this is a velocity time graph given. This is a velocity time graph, and two graphs are there. For body A, this is the straight line graph, and for body B, this is the straight line graph. Okay. For body B, this is a straight line graph. We have to tell which body will have more acceleration. We have to tell which body will have more acceleration. Which body will have more acceleration. So acceleration is the slope of velocity time graph. Means what we will do to find the acceleration of A or acceleration of B, we will find the slope of A or slope of B. Okay, so slope of A, slope of A, slope of A is, what is this? This A is making an angle of theta 2. So it will be tan theta 2. And the slope is the acceleration of body A. Now slope of B. Slope of B, this B is making an angle of theta 1. So tan theta 1. And this will be the acceleration of body B. Now we have to find whether tan theta 1 is greater or tan theta 2 is greater. We know that which angle is greater, theta 2 or theta 1?
Theta 2.
Theta 2. So we know that theta 2 is greater than theta 1. And both theta 1 and theta 2 are lying between 0 to 90 degree.
Yeah.
So theta 1 is also lying between 0 to 90 degree, and theta 2 is also lying between 0 to 90 degree. And when you will take tan theta on both sides, so it will be like this. The value will be positive of tan between 0 to 90 degree. When you will take tan on both sides, tan theta 2 is greater than tan theta 1. Means the slope of body A is greater than the slope of body B. You can see here also this slope is less slope and this slope is more slope. So slope of body A is greater than slope of body B. Means you can say acceleration of body B is greater than acceleration of body A. Oh, no. Acceleration of body A is greater than acceleration of body B. Because, okay?
Yeah.
Now, next question. So, by solving question, the concept will become clear. This question is given and it is asked that which body will have the more acceleration. Body will have more acceleration.
B.
No, A. Why? You can see the slope of A is more as compared to B.
Yeah.
So we can calculate that. Means you can see which angle is greater, theta A or theta B?
Theta A.
Theta A is greater. So if theta A is greater than theta B, then you can say tan of theta A will be greater than tan of theta B.
Yeah.
Means slope of A will be greater than slope of B.
Yeah.
Means acceleration of A will be greater than acceleration of B. Now after this, one more thing. Area of velocity time graph. area of velocity time graph. So this concept is very, very important. Area of velocity time graph. Always remember, with respect to time axis, area of velocity time graph will give you the distance displacement.
Yeah.
Gives displacement. Okay, if the velocity time graph is like this, if the velocity time graph is like this, one area is above the time axis, one area is below the time axis. So you will take this area as positive and this area as negative when you are calculating displacement. When you are calculating displacement, so with sign you will take areas, and when you are calculating distance, you will take no sign. You will take all areas positive because distance is always positive.
Yeah. Okay.
For example, this area is 2, this area is 1. If someone is asking what is distance, so what you will say? It will be A1 plus A2. And A1 is 2 and A2 is 1. So it will become 3 meter. And what is displacement? So you will say A1 minus A2, not A1 minus A2. Means you will do A1 plus A2, but the value of A1 is 2 you will take. But this A2 value you will take negative. Means minus 1. So 2 plus minus 1 means 2 minus 1. That is 1 meter.
Okay.
Now some of the questions we will solve. I am solving this question. We already solved this question in the last classes, but again we are solving. Has your teacher given any information about the syllabus?
No, not yet.
Okay, it's fine. So from the velocity time graph, basically this is a velocity time graph. From the velocity time graph given below, for a body projected vertically upwards, find the velocity of projection. Find the velocity of projection. Velocity of projection means, suppose a body is projected upward like this. So if the body will be projected upward like this, so they are asking with how much velocity you have projected the body, means they are asking the initial velocity. Now, after some time, the body will come back to the ground if the body is thrown from the ground. And this is the maximum height of the body. This will be the maximum height of the body. After a certain height, after going to certain height, body will stop and it will come back. Okay. So find the velocity of projection. Velocity of projection they are asking. So how we will calculate? Velocity of projection you can see here. This initially at t is equal to 0, we have two velocities. One is this minus 20, another is plus 20. One is minus 20, another is plus 20.
Yeah.
And I told you when the body is going up, when the body is going up, what will happen? Suppose I am projecting this pen upward. So initially this pen have more velocity, and finally the velocity of this pen becomes 0. After a certain period of time, the velocity of pen becomes 0. You can say here, you can see here from this graph, initially the body has a velocity of plus 20. Why? Because the body is going in the upward direction, and upward direction we have taken positive. So the velocity of projection from this graph you will get velocity of projection you will get plus 20 meter per second. Here will be this is not here, it is meter per second. Okay, so this is clear.
Yeah.
So now from here to here, the initially there will be some velocity of projection. After that, when the body will go up due to the gravitational force, because on this body the gravitational force will act in downward direction. Due to that gravitational force, the velocity of the body will decrease, and there will be a point where the velocity of the body will become 0, and after that the velocity again due to the gravitational force of attraction will come down. Means again now after reaching to the maximum height, again the velocity of the body will increase, but now body is going in downward direction, and in downward direction the velocity of the body is decreasing. Means negative direction the velocity of the body is decreasing. Now you can see graph. Initially the body is here, initially the body is at the ground. So if the body will be here, here is the body on the ground. And on the ground this is the projected velocity. When the body will have the 0 velocity, what is the position of the body? The body will be at the maximum height. When the velocity of the body will become 0, it will be at the maximum height, na?
Yeah.
Okay. So in achieving maximum height, how much time the body is taking? T is equal to 2 seconds.
Yeah.
And what is the initial velocity of the body? 20 meter per second.
Yeah.
So we can find the maximum height. We can find the maximum height with the given data. Suppose h is the maximum height, and final velocity of the body will become 0. Now body is going in upward direction, and acceleration, there will be the acceleration of the body, that is minus g.
Yeah.
So now apply v is equal to ut plus now maximum, for maximum height apply this formula. S is equal to ut plus half at square.
Yeah.
Instead of this s, body is traveling 0 to h height. So means
Yeah.
s displacement will be h, and this displacement will be positive. Why? Because body is going in the upward direction.
Yeah.
So h, and what is the initial velocity?
Initial velocity. 0.
Initial velocity is this, na, u.
Sorry, 20 meters.
Velocity of projection will be the initial velocity 20.
Yeah.
How
Yeah.
much time taken? 2 seconds.
2 seconds.
Plus half. What is the acceleration? Acceleration you will take negative, minus 10. What is the time? 2 square. It will be 40. 2 and 2 will be cancelled out, minus 20. So maximum height will become 20 meter. So the maximum height of the body you will get 20 meter.